TLDR. I'm gonna go pretty to the slides. There's a bunch of slides. I'm happy to share the slides, and I guess you can also maybe hit me up on Telegram or hit up Rado if you have questions. So yeah, why would you want to build on the internet computer? The internet computer is a blockchain with a ton of features not found elsewhere. And actually, maybe it's not so much a blockchain, but rather a decentralized computer. So it's really like a, blockchain or like Bitcoin, right? It's the most secure ledger ever. And what Bitcoin is a blockchain that maintains a ledger. The internet computer is like a blockchain that maintains all kinds of codes, all kinds of data, just in the very same thing. So it's really like a ledger on like a ton of steroids, and so it allows you just to implement any sovereign secure software. ICP has network integration with Bitcoin. Actually, ICP smart contracts can own Bitcoin, can process Bitcoin. So it's really like a layer 2 to Bitcoin in many ways if you want. You can also do like with EVM chains. So there's an RPC, like the threshold RPC. You can also talk to EVM chains. Bitcoin is natively integrated, so it's a bit different. But like as a developer, it doesn't. I guess it matters in terms of like what you get, maybe in terms of security, but as a developer, you can do both. The ICP smart contract can own any crypto, transact any crypto. There's even like bridged version of Bitcoin and the ERC20 tokens available natively on the ICP protocol, just so you can transact them much faster and then like swap them in and out to Bitcoin or from Bitcoin and like Ethereum and so on and so forth. It also hosts like a DAO ICO launchpad, which maybe is interesting for you guys in the future. If you build a cool project, then you can also do like ICO like 2.0 in some sense, right? On the protocol allows that as well. So I'm with the DFINITY Foundation. So I guess we are sort of like a very cool bunch of people here. A lot of like people have like histories in crypto, distributed computing, top-notch scientists. A lot of us come from like academic backgrounds, eventually PhDs, but all of us care about coding, care about changing the world, and actually have like not about writing papers, but actually it's all about code working, being secure, and running fast, and all of that. So I guess engineers at all the complex stuff is secure and works out. We have like 150, 140 people here in Zurich, so that's also very cool to work here because you can really quickly step on a whiteboard and solve the hard problems and then get it out. And our mission is really like on-chain is the new online. So we want to bring like all of the world software, or almost all of the world software on a blockchain. I guess in some sense we don't care about which one. It's also not like blockchain. Like it doesn't matter which chain. It can also be like a whole bunch of chains. So that's actually we care a lot about chain fusion and want to make ICP smart contracts also like interact with other smart contracts. That's really the power you can get from ICP. You can, like in some sense, this chain abstraction or chain ignorance, if you want. Right? And so the internet computer is really like a blockchain. It's very powerful. It can play the role of like the next version of cloud because you can really build almost everything here. All from smart contract software. You don't need anything on Amazon or anywhere else. So I think a lot of people in the industry that they build mostly stuff on Amazon, maybe also because it's fast to build it there, and then have some tokens on some other chain. But we really believe everything should be smart contracts, and we want to really enable that. So it's really like blockchain reimagined, because now if you want to host around like all the world software on a blockchain, then I mean you have to overcome some of the quirks like that you have if you just are like run on a ledger, so or on like an Ethereum or anything like that. So first of all, like a smart contract on ICP actually pays for its own computation. So user don't have, the user can interact with a smart contract, can use a smart contract without having any crypto itself. They don't have to install wallets. All a user needs is just browser. So smart contracts can actually directly serve user experience into the browser. So that's like a huge advantage like nobody else can do that. And the internet computer has been up and running since May 2021. It's never been down. It has been actually upgraded 310 times. Like, I guess other chains would consider that, they did fork 310 times. You see some stats here. You can go to the dashboard to see some of that, right? I mean, like, there's actually 300, I guess this is outdated, 131 different node providers. So these are different parties that own physical hardware. So it's very much like Bitcoin in that sense, where you have like a miner hardware. Here is like when top-notch server machines. These machines are in different data centers all over the world. You see the bubbles here, and it's running like crazy.
Yeah, and are you talking on another slide? Because it's still on TLDR right now.
Is it?
Yeah.
It's actually super annoying because it should be like that. Can you, I mean, still?
Yeah.
Because here's what I want.
Yeah, can you go to the right-hand side and click on the paintbrush, the format, so we can make this a bit bigger? Upper right-hand corner.
Here.
Upper right-hand corner, you see the format in your keynote. Right side. Right side.
Here.
Sorry, your other right. The right side.
Sorry, my other right.
Yeah. Format. Hit format.
Like this one? Or just this?
Left.
Oh,
Yeah,
sorry,
format.
yeah.
Or document. Yeah, get rid of that right-hand side. Hit document again. No.
Sorry.
There you go. Good. Yeah, there you
Exactly.
go. Beautiful. Thank you.
So I guess here's, you also use information on the dashboard and so on and so forth. But now let me dive in what actually the network looks like. So, I mean, as I said, if you see this, these are the different server machines running in those data centers. Again, they're owned all by different node providers. So it's not like none of that runs on Amazon, right? And if Hetzner decides to switch things off, we don't, the internet computer doesn't care at all. It's like it keeps running because they're all independently owned all over the world. And the ICP, the Internet Computer Protocol, actually then groups these things together to form efficient subnet blockchains. And so these are actually, these are then computers that do replicated computation, right? So smart contracts that run on those subnet blockchain, and so these smart contracts run actually on these nodes here and not on other nodes. So that's how you can scale efficiently, and that's also how this can run fast, right? So essentially, a smart contract can get like one core of one machine running full speed, and then another, I guess there's many cores here, so that's why I can have host many smart contracts at the same time. And of course, they can talk to each other. And so, as I was saying, right, I mean, these smart contracts can actually talk to each other. It doesn't really matter on which subnet it is. The protocol takes care of that. It's just native calls. Obviously, if you're on the same subnet here, if this guy calls this guy, it's much faster because then actually they also can communicate at full speed. If you talk across these subnets, then of course communications is slower because then you have to run through rounds of consensus. So as a developer, first of all, you wouldn't, you can be agnostic to that. If you want to, of course, do your replication with a bunch of smart contracts that talk to each other, you can just make sure that they run on the same subnet here. So that's like really high level, but very fast how the Internet Computer Protocol works, why it can be fast, why it can scale like crazy. But actually, I think what is more important is actually what's the user experience here, right? And so maybe let's go here. So as a user, I can interact with smart contract just with my normal, like my phone, like a browser. It's really all you need on your laptop and whatnot. And so every smart contract actually has a URL. And by just entering the URL of your smart contract that you want to communicate with in the browser, you can already talk to it. Now, of course, not all of them would serve web. Some of them would just not do much when you talk to them your browser. But so typically applications would have a front end that serves the web, that you can interact with that, and then it would have some back end. And the back end can actually be hundreds of canisters, hundreds of smart contracts. Like OpenChat is something like that. Viral is another one. So OpenChat would have oc.app as the URL. Viral has YRAL I forget, I guess .io, whatever you find it out as a URL, and then you already talk to a smart contract. Now, how is this secure? How does this work, right? Because now you're talking to a browser, you're talking to a smart contract, to the internet computer, but results you're getting are actually from the smart contract, not from somewhere else, right? And the idea, the way how this works is like the internet computer actually has like a single public key, and all the transactions are actually signed with that public key. Of course, there's like a bit of a key hierarchy in here, but at the end of the day, on the browser, all you need on a machine is like have this public key, and then you can actually authenticate any message. On the other way, also like there's something we call internet identity. So when users communicate to like a smart contract, you can use WebAuthn, they can generate a principal, and then you actually have a secure session between the browser and the smart contract over the internet, right? So they can talk directly with that. That's actually very cool.